Now, the last thing that we're going to be talking about in this handout for the alkenes and the alkynes are the cis and the trans isomers. And so in this case, what we're talking about is really the same arrangement of the carbons, but something happens when we actually put a double bond onto the main chain. So if you were to take a look at these two molecules that I have in front of you on this video, you're going to see that both of them look very similar. They're made with 5 carbons, so it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and they both have this W shape right over here. And the only difference right now is that there's this double bond. So what makes it different? And so the idea here is that when you have a single bond, what ends up happening is around this bond right here between the second and third carbons, there is the ability for that molecule to be able to rotate. So right now I've changed it from a zigzag shape to this sort of like almost like a Big Dipper shape. But if I was to try to actually twist this and try to turn this molecule, this double bond actually prevents it from happening. And so what ends up happening is when you have a double bond, it actually locks the formation of these two carbons, so it prevents that molecule from twisting. So therefore, this is stuck in that W shape, whereas this one over here has the ability to change from that W shape into that sort of Big Dipper shape. And so if I was to put in now a third molecule with the other configuration, this is now that double bond in that Big Dipper shape, but I cannot twist it to actually force it to become this W shape. And so as a result, there is now another component to naming, which is taking a look at that orientation of the main chain around this double bond. And so in this case over here, if I was to take a look at these two molecules, one of the things that we want to see now is how are they different? And so the best way to see this is that if we were to actually identify a plane going through that double bond, if you take a look at this main chain over here, what ends up happening is one part of the main chain is below that double bond and one part of the main chain is above the double bond right over here. Whereas if I was to put a sort of plane along this double bond right here in the bottom molecule, you're going to see that down here you have the main chain below the double bond, and then on the other side the other main chain is also below that double bond. And so what we have now is we have to give it another prefix or indicator to show this particular arrangement. So I'm going to draw this right now. And so if I was to draw this right now, I'm just going to pull this down a little bit, and I'm going to have this carbon. It's going to go up with this double bond, and then this is going to go up like so. And then you also have the second one over here where you have this carbon and it goes up and then it goes down like so. And so how are we going to name this? So if I was to, first of all, name with what we have done so far, this is going to be 1, 2, 3, 4, 5. And so this is going to be 2-pentene. Now, if I was to take a look at this one over here, this is 1, 2, 3, 4, 5. This is also going to be 2-pentene. So how do we differentiate between this one and this one? And so in this case, we actually have another sort of indicator. So if I was to draw a plane over here, so this main chain and this main chain are opposite sides. So what I would use is I would use the term trans. So trans means opposite. And then in this case over here, if I was to draw a plane right here, what will happen is that these are on the same side. So to indicate that they are the same, we use the term cis. So cis 2-pentene, and this is trans 2-pentene. And so what this will do is it will tell you the way that the main chains are oriented around that double bond. Now you might say, well, it just seems like that there's a lot to remember, and there is. And so in this case over here, what I will say is for our purposes, when we go about naming this, if I was to draw the molecule and it's going to look something like this, I am not going to require you to tell me whether it's going to be a trans or cis, and you're just going to name this just normally as 2-pentene. However, if I draw this in such a way that I'm indicating the orientation of the main chain around that double bond, then what will end up happening is then I will be expecting you to be able to tell me whether it's a cis or trans. Now, your final question will be, well, do we have to do this for the alkynes? And the answer is no. And if I was to show you this molecule right here, okay, with the double bond, and then if I was to show you this molecule right here with the triple bond, you'll see that this molecule is completely straight across. So there is really no variation in terms of where this main chain is and this main chain around this triple bond. And so therefore, for an alkyne, there is no need for you to identify whether it is going to be a cis or a trans orientation around that double or that triple bond. So this is only specific to just the double bonds.